today's lecture. I want to welcome you again. We have a very prolific scholar in our midst today, in person of Mr. Babatunde Adedeji. He has worked together with me, have published papers together. He's very vast and versatile, both in academia and in the industry. He has worked as an engineer with Dangote Group, and he's also a very erudite scholar. And recently, he has, by quest of more knowledge, he has gained admission to one of the best universities in the US to do his PhD with funding. So he's here to show you how to profit doing data science research. Mr. Adedeji, you are welcome. Please have the floor. We're happy to have you.
Good evening, everyone.
Good evening, sir. Good evening, sir.
Good evening, sir. Good evening. Thank you, sir, for having me. Good evening. So thank you, sir, for having me. Thank you, everyone. It's a pleasure to be here. So we'll just start. It's going to be a bit conversational, and then feel free to stop me at any time to ask questions during the presentation. So I will just go ahead and share my screen now. I prepared a slide for us. It's going to be conversational. So I just want to share my experience with you. Sorry, a minute. All right, can you all see my screen now?
Yes, we can.
Sorry, please. Okay, you can. Okay, thank you. So I've titled today's presentation, Excelling in Data Science Research. And I'm not shocked. I'm just happy that, just like during our time also, we came in to ADA, not really knowing much about. So we've had just a bit of the skills, like, how to do supervised learning, carry out and supervise and all of that. But you're not really sure what you want to use your skill, to do that. You're not really sure. Maybe you want to do like majorly data science, maybe where you freelance and projects. But then in your heart, you feel like, oh, maybe I also want to do research. I want to do my PhD and all of that. So this was the junction where I was when I found, or when I came across ADA. And I was able to conclude in my heart, this is what I really want to do with my data science skill. So research, yes. So I've titled it Excelling in Data Science Research. So a little bit about me. My name is Babatunde Adedeji. I had my bachelor's in chemical engineering at Obafemi Awolowo University. I graduated, say COVID, it was supposed to be 2020, but eventually 2021. And then, shortly after my graduation, through my friend, I came across ADA, where, I was mentored. Like Prof mentioned earlier, I worked with Prof, I was mentored, and then we had a number of papers together. And honestly, trust me, these papers were, they really came in, in it at a time where I needed them to also, like you mentioned, like when I was applying for my postgraduate studies. Recently, I got accepted to Tulane University. Tulane University is one of the top 100 universities in the US, highly reputable. So I got a PhD, fully funded PhD for chemical and biomolecular engineering. So I'll be resuming this fall. So that's about me. So during the course of the presentation, we'll talk more about the process and how the data science research can help you get even much more, right? Things done. So this is just a little word of encouragement from me that, go the distance. Like all it takes is just for you to push till the door opens. It's learning is not easy. It's not going to take a day or 2 days. Just like Mr. David Akinwale said the other time, oh, sir, we're going to explain when we meet. We're going to talk about it. And so in my mind, I'm like, I just remembered also that, there were times that I would, Prof would say, oh, so let's meet by 10 p.m. At 10 p.m. till 1 a.m. Prof would say, okay, why not work on that? So maybe I'll be expecting the next 2 hours. In my mind, I'm like, this is like the middle of the night, sir. I thought you would say tomorrow. So it's going to stress you a bit. But then when you see the paper published, with your name on it, not just in any journal, but a global journal in Elsevier, and all, you'll be so happy. Honestly, I can't really explain it, but it's just going to be a huge achievement for you. And so it'll be worth it. So I just hope you are ready for that. So let's talk a little bit about the data science resources. Just also making reference to the presentation Mr. David did earlier. I was just looking through the tabs on his browser. I just hope I'm correct. Mr. David, you were the one presenting the other time, right? Or Prof?
It was me, sir.
Okay, yeah. So I saw your tabs and I was looking at the icon, seeing Python, seeing, I saw SciOp and all the other resources. And I'm like, yeah, you get the gist. Because you're going to have a lot of those resources that you will need to take advantage of them. So now the skill is important, right? You know how to carry out your fitting, clean your data and all of that. But then, just like I said, the title of the presentation is excelling in data science research. So you must be able to really know how to take advantage of these resources, right? To be able to excel in the projects you're working on and some other engagements you will have in data science. So here are some tools, which I know you're already working with this tool, but or these resources, you're already working with them, but I just want to bring your attention back to, just in case you are familiar with them already, and maybe you just need to be reminded. I'm sure you know about Google Colab, and that I know that most of the software you're using is more of Jupyter Notebook, right? And in data science research, you're going to at some point say you want to carry out a particular, you want to fine tune your program, and so you need help. Maybe like there's this. Okay, say for example, you've carried out. You're trying to look at how to take advantage of, say, neural networks, for example, on a particular project. And then maybe you've done like the, say, okay, you're working with a continuous data, like a time series. And what I mean by time series is like a data that is, let's say, for example, you're taking the temperature or, like a meteorological data. You're taking the temperature, the ambient temperature, the humidity, and all these things. You're taking them over the span of, like, say, every one hour of every day, every week, every month, then for the whole year. You can imagine the amount of data you accumulate over that span, and you want to study the changes, that occur in this data over time, right? So that there are specific machine learning models that you use, right? And these machine learning models will respond differently. Some based on the kind of data or how it's been cleaned, and some other factors that will affect. So they will respond differently. Say you are using like CNN, and then somebody just say, yes, I know CNN will perform very well, but have you tried LSTM, long short-term memory? Oh, I'm not really sure how to do that. Do you get? But you know how long it will take for you to now start learning LSTM. But then because of the resources that are available already online, you can go to like GitHub, and then see maybe somebody has worked on that and all of that. And then you see somebody who has worked and you really like, it's similar to what you're doing. What you just need to do is learn, the flow. Can you hear me? Just let me take a pause to be sure that you can hear me. Sorry, please, can somebody respond?
Yes,
Can you hear me?
hear you.
Okay.
Yes, I can hear you.
Oh, okay. Thank you. So then you want to learn LSTM. You've never heard of it at all in your life. Okay, I want to learn LSTM. Then you go online, GitHub. You see several options. Then you like the particular option. But one thing is, the link is maybe the code is on a Google Colab. You understand? But you'll be amazed that in as much as Google Colab is like the online, is like, very similar to Jupyter Notebook, right? But you agree with me that the syntax is a little different. There are specific syntax that are like, if you're not familiar with the use of, Google Colab, transporting the whole thing, and you remember that the bulk of your work is already in Jupyter Notebook, you only need the LSTM part to just transport it to Jupyter Notebook. But now you have the solution in Google Colab. You need to collapse it and bring it to Notebook and find a way, to fit it with the work you're doing, right? So now, because you are familiar with Google Colab, it will save you time, effort, and, it will reduce your frustration because you already know that, oh, this is what this means, this is what this one means, and then you just quickly, oh, so this is how to do it, and you know how to transport what you have, in Google Colab to, Notebook, your Jupyter Notebook. And I'm assuming that, of course, we're already working with Jupyter Notebook. And is anyone here, you've not heard of Google Colab before? It's fine if you have not heard of Google Colab before. Just want to be sure. Hello? Nobody, right? So we all know Google Colab, right?
Yes, sir.
Yes,
Okay.
yes, please.
Okay, perfect. So so it's just like a refresher, right? Good. So have you heard of Free Code Camp before too? This one is not
Yes.
it's not
Yes,
an
I
high.
am.
Yes, and how well do you use it? It's interactive, right? It's an interactive class. I just want us to have conversation so that how well do you use Free Code Camp? Or how often or you don't use it at all?
For me,
Sorry,
I've not
sorry,
used
is it
Code Camp.
okay? Isn't it for learning?
I've never used it, but I know it's for learning a lot of coding.
It's for learning.
Exactly. So it's actually is a very good resource. I mean, there's the online version, but most of the times also there is the also people use the YouTube. There's a YouTube channel also, right, for it. But there's also the online version, right? But the YouTube most times, right? People use it to just like refresh, and sometimes also there are concepts that you will need a lot of manuals and textbooks and just so many information. So it's almost like they help you to say, for example, you want to learn everything, maybe the most important things about supervised learning. Do you get? And then you don't want to be running around online checking material. Sometimes I do it. I just type supervised learning PDF. So you want to see some professors have worked on it, presentations upon presentations, some textbooks where you open and then you're almost lost in many words, right? But then you want a place where they do like a 2 hours, a 3 hours overview of everything you need to know about supervised learning, just a paraphrase. Then you can now maybe, if need be, go deeper into some, specific topics. You understand what I'm saying? So Free Code Camp, honestly, in my opinion, is really, really valuable resources. So I know you've heard of it, but you might just want to also, look at you can go to YouTube, check their playlists, and you see some wonderful concept there. Mr. David was talking about random forest the other time, right? So sometimes you run into some certain troubles, maybe because even when you go online GitHub and then you see some code or you're writing some codes that will not work for the specific data set you're working on because of the kind of data sets. Do you understand? There are some data sets that the features, right, is either is too large or is not enough. You agree with me, you're trying to train a model, right? Say you're doing like classification, is a classification problem. Do you get? So you have your target feature, say, for example, say obesity now, or no, not even obesity. Let's say, what's this? Sorry, say, let's say cancer. You want to predict if a patient is going to have cancer or something. So you are checking the likelihood. Is either yes or no, right? It's a classification problem. Either they have or not. So you're trying to check it over, certain maybe like 30 factors. Say body weight, their height, the sex, either male or female, several these things. You agree with me that for a data set that contains that likelihood versus just 5 features, say, and another data set that you are checking for the likelihood versus 10 other, 12, 15, 20 other features. So if you write the same code for these 2 data sets, chances are excellent that you have some models that will perform well in dataset A or with dataset A, right? But then will not perform very well with dataset B, just because the features are quite different and the nature of the features that you are checking them for. So these things pop up in data science research, and sometimes it takes days. For example, there was this work, I did with Prof one time. So we're trying to learn, use emerging data calibration techniques. Yes. So we didn't want to use the traditional one. So Prof was like, okay, let's just try this. They're not necessarily new, but people have not used it so much. Call it spline and beta calibration, right? So this particular data set we applied, we just noticed that spline did not perform very well. In fact, in some cases, it was not even performing at all, right? But beta calibration was doing well and all of that. Okay, you know what we'll do? We'll still need to work on this spline standalone. We'll just work on spline calibration alone. So because of that project, another project came out of it. And this, we started, going extensively. We use different data sets. What's it called? sample spaces here, different sample spaces, 20,000, 10,000, just to see how the calibration technique will respond to each data set. So how large is your data set will also determine your code. So the code you use for 10,000, right? Sometimes you have to tweak it. Do you get? So all of these things, you learn it during the project. We're going to talk about it in the course of our conversation today. Notebook. I just listed this. I know you guys are guru already. How many weeks you have spent with Prof. I'm sure that you've learned a lot of things now already, and I'm proud of that. So there's the AI tools. Of course, I know you guys even know probably more than me on this, AI tools and all of that. But of course, you agree with me that my Oga at work will say PGT, but of course, ChatGPT, is very valuable for help to it will help you to learn not just the code. For example, I was talking the other time about you getting some code online, GitHub and all that, but it's not just copying the code and just pasting it. And no, somehow you also need to understand, why are we using this particular syntax? What is this particular line doing here? What are we trying to achieve with this? Because you are learning. You're not just writing these codes to publish papers. Hope you know that. So you are learning so that eventually, along the lines, maybe you want to continue, you want to do your graduate school, prof will be recommending you. And at some point, even some of these professors will even want to, call, they will reach out, they might even want to reach out to prof and say, you work with this boy, okay, so he can vouch for you. So while you are learning this, you are writing this paper, you're also learning the flow. So sometimes ChatGPT will help you to really understand. So you can always prompt and say, oh, this particular line, what is it doing? Can you explain further? Is an interactive tool. Hope you understand. So before I proceed, I just want to just a little break. If you have any question, you want to bring my attention to something, you can just unmute and bring my attention to any questions so far. I just want to be sure that you're with me. Okay. Yeah, you can go ahead. I can't hear you, Sister Iberia.
No, I don't have a question. I wasn't speaking.
Oh, okay, nice. Okay, but we are following so far. It's not boring. You are enjoying it.
Yes, sir. We are with
right?
you. Yes.
It's not boring.
Oh, okay. Thank you. Thank you for the encouragement. I'll take that. So let's talk about research resources, right? The other time I saw, just again, Mr. David using SciOp, right? And I assume that also you're trying to use that to get papers. There are some papers that research articles that you can't get on Google, and then you need to go somewhere else and get it. Usually we use SciOp. But at this, of course, this section is going to be a little bit more interactive because I want to know if you know these tools. And I want to ask you, I know you're using Overleaf. I know you've seen Google Scholar, and you most likely you're using it, right? So I want to ask you, I will go from Miss Bosede, right?
Shagun is a man.
Mr. Shegun, apologies, sorry.
Yeah.
So, Mr. Shegun, do you have a Google Scholar account?
No, I don't have a Google Scholar account.
Okay, because I will assume it's because before you open a Google Scholar account, you must have published a paper online, right?
Yes.
Okay, so I asked that question because, of course, you're on your way, right, of course, to publishing a paper so that you can have a Google Scholar account. And when you have it, and if you are interested in postgraduate studies, usually these are very good stuff. So you can always put it, in your CV to be part of the header. So where you have your address and all of that, just put your Google Scholar, put your other stuff there. Is going to be very, very. So has anybody heard of SciSpace before?
No, this is the first time I'm hearing
Yes.
that.
Okay, sorry. Who's saying yes? Please unmute yourself.
I think I have. I'm
You
not
have.
mistaken. That one.
Okay. Have you been using it?
Yeah, for my research. Yes, I think I've used them. Yes, I've used them.
Okay. Okay. So,
Yeah,
and
I've used,
can you tell me about it? Can you tell me about it?
okay, basically just to help with research writing. So I think you can type a topic and it gives you methodology, it gives you literature review, summary, and then I think there's a chat box where you can also ask questions, and it gives you, as in like, it just summarizes the paper, again, literature review, methodology, and just different things about a particular paper. So basically, it just takes the paper and extracts the important information.
Okay, that's beautiful. So for others who have not seen it, I'll just put it up now. You get so that you see it's very wonderful. Honestly, Mr. David mentioned earlier about his work that they've not really done much in that area. And in my mind, I'm like, exactly. So you use size space to get to know research gap. You want to know if okay, what are the issues. So let me just, can you see my screen now? So I just want to
Yes,
show
sir,
you
we can.
size space. So this size space, it's not totally free, but there are features there that are free. Like you can still use without paying. Just create an account, sizespace.com, right? So, so usually what I do is to just come to this literature review part, right, and just query. Let's say, for example, I want to know spline calibration, right? You see that it's already suggesting the kind of questions I want to ask. He's saying thinking. He's thinking for you, right? He said, could you please clarify which aspect of spline calibration you're most interested in? You can see that. So now it's helping you kind of, to narrow down your work. So let's say I want application areas. Let's say I want the application areas, right? Beautiful. So, but then most time, because you have not paid, you won't get this feature. This is like the deep review. I'm using a paid account, but so we'll just come to the standard one. This is the standard one. This is one that everybody is still very much, it's still going to be valuable to you. You see these papers now? You see the paper. So with size space, you have access to more papers than SciHub. Do you understand? Size space has, most times in SciHub, if you want to, download 2023 paper, latest paper, you won't be able to get it. You agree with me, right? Most times 2024 papers you can't download. But here, I can filter this to like, say 2024, last 3 years, you see, and just apply it. I want spline calibrations, with the work they've done within the past 3 years. So you look at this now, it was published 29 January 2024. Do you get it? Even though this paper is not available for download, this is like a request PDF, yet I can still use this software to prompt the data. Now, this is the insight from the data. I can say, oh, I want to know the result of the data. You just click here. It will give you another column for the results. In this paper, they were able to reduce PSF intensity overestimation by 67.8%. That's a breakthrough for the paper. Do you understand? They were able to improve. So I'm like, okay, how did you do that? Like Mr. David mentioned earlier, that the methodology is solid. So you go to method use. So how did they do that? Are you following?
Yes, sir.
Yes, sir, we
Yes.
are.
Yes.
Yes, sir, we are.
Yes, we are following.
So you see the method use, novel spline model for depth. Oh, this is wonderful. Interpolating, oh, I'm like, oh, I love this already. And then you're like, okay, now I want to know, were they able to, so what are the challenges they had? So you want to know, you just go to challenges. So they had issues. The conventional calibration methods perform poorly at few micrometers depth. You see that I was mentioning the other time that all your data will not perform the same way with the same code. That sometimes the problem is not your code, the problem is the data set. Do you understand? But then this paper will now point your attention to, oh my God, this thing will not work at this particular. So you know that if you are facing the same problem, you're not alone. This paper is already showing you that there's an issue here and all of that. So when you are writing your own paper, it's still a result. The fact that it's not working does not mean that you are the problem. It's still a result. And now you have papers that can back your claim up. So your paper, you can now write and say, oh, this thing did not work. And of course, it's been an issue, even with other papers, they now cite it according to Seraphim and Dylan or Seraphim et al. 2024. It also did not work. You understand what I'm saying? So and then there's just a lot you can also do with size space. You can chat with PDF. Say you get a paper, you were able to download a paper from, let me say here now. Let me say I'm uploading a paper. Say I want to chat with this paper now. This is an article now. So you can chat with it, interact with it, and say, can you summarize can you summarize the idea of this paper? The whole idea or idea of this paper, right? So I don't want to waste my time, just ask the paper and then it will just tell you that, okay, you see that summary of the paper on cohort myth is one of the works that I've been working on. So introduction to cohort myth, okay, so the paper, the public perception, and of course, this one is not data science related and all, but any paper at all, you can upload, chat with it, because you want to. So most of the time, literature reviews, you download a paper and then scan through manually with your mind. But with the help of AI like SciSpace now, you can interact with papers and it begin to give you insights. And you agree with me that it's still the work of data science, because what's the name of this GPT language is what's the name
language
now?
processing.
NLP.
NLP.
Yes, natural language processing, right? So it's still the AI model here. It's still our work. Do you understand? So it's beautiful that data science is also helping data science research. Beautiful, right? So this is like SciSpace. Wonderful. Honestly, I think you should use these resources. Very, very nice. So I'll just go back to the presentation. Do you have any question, maybe about the login, about the use, and what or any other related question? Okay, so I'll just assume we don't. Okay, so there's Overleaf. You guys have been using is Site. Site is also very similar. Site is also very similar to Site is also very similar, right? To SciSpace. So you can choose to use Site as well. Very, very similar. But I don't have a paid account for Site since I have SciSpace. But Site is also, you see, the schools, even UCLA, Frontiers, these are paper publishing companies. And then, all these companies, they use it. So Site is also very popular and very, very important. So there are other list of resources here. I think probably I'll just share this also slide so that you can just check also. It will make your work more efficient, call down time, so you'll be able to get, just write your program and all of that, and then you won't be running in between materials and getting frustrated. No, it's going to just shorten. You'll be able to work on multiple papers, also work on, more papers within a short period of time. So that is about that resource. There are other resources, honestly, but for the sake of time today, sake of time. So I just want to tell you about tips on data science research. Okay, like I've been saying, learn your tools. Of course, learn your tools. I'm sure that you guys have been learning it. You're not going to learn everything. So don't wait till you learn or you become a pro, before you start working on projects. And thank God that's what you're doing already. You agree with me that you've learned a lot of things, even now that you've been working on some project. It probably started off as, oh, I'm not sure I'm going to be able to do this. But then you started doing it little by little. And then you're getting familiar with the tools. And honestly, it's making sense, right? So that's the way you become a pro. In data science research, we learn on the job. Do you get? We learn on the job. You learn on it. That is how to excel in data science research. And after you've learned on this, so don't worry. I know maybe you've been working on some data sets and you feel like, I'm not really sure. Hey, I've been working on maybe clinical data set, or I've been working on this, but there is not related to my area of this. No, data science is not like that. You agree with me that in data science, the major emphasis is on the method. Do you understand? First thing is that you learn the method. Then you are now at liberty to apply to whatever thing you want to apply. So you can publish paper in, say, with clinical data sets, and then you're an engineer, and you look like, oh, how does this relate? It does, because for anybody that will engage your service, maybe either postgraduates or anyhow, they don't really mind, what data sets you've worked on. They are just really sure, are you familiar with your tools? Can you make sense? Can you process, a problem and be able to conceptualize it and know the method to apply, know how to really solve the problem? Data science is about solving data-related problem, modeling, predicting, thinking. Do you understand? So it's not really about the data set. But after you've learned the methods and you are confident that you can carry out research on your own, you can now proceed to like applying it to your own niche. Say, for example, for me, I'm an engineer. There are a lot of things, honestly, even as an engineer, sorry, I didn't say earlier, I'm currently an engineer also in the Dangote fertilizer. So I apply these things to my work. I applied a lot, a lot. These same methods, but I started, data science with, a clinical data set. But it does not matter because I'm applying it to what I'm doing right now. And it's really helping me not only stand out, but it's also helping me, that I'm up to date with my work. I'm able to cover what maybe others would do for a longer time. I'm able to do it over a short because of the idea of data science. So identify your niche. I mean, which area do you want to apply the data science? Data science. So also at Ada here, one of the things I'm sure, of course, Prof would have also told you is that he wants you to work on a project and he also wants you to collaborate. In Ada, we learn collaboration. We learn to work with other people because you will need it. Postgraduate, workplace, there's going to be a lot of collaborations that we will do. And here, you will also learn collaboration and strive to publish papers. Prof will tell me, oh, today let's publish one more paper. Yeah, you publish one more paper. Even when I was worried about graduate school, Prof will say, let's publish more paper. It will make you stand out. Then you drag, and then you drag yourself and publish more papers, work on more projects, because you are developing yourself while you wait for your big break, big break, to catch your big break and excel at that thing you're targeting. Because while you wait, you also learn things. Because now I'm checking my school curriculum. And then we had a meeting with the department and they did a breakdown of our PhD program. And honestly, I was shocked that a whole course is about data science research. You will not believe it. A whole course. And it's an undergraduate course. And me being a teaching and both teaching and research assistant, I'm assuming that at some point I may be working because of the data science background. You know how graduate school work? Like when you submit your CV and your profile and all of that, that you have first class is not the reason why they will bring you in. They bring you into the program because of their needs. So say, for example, the professor handling data science, the data science course, needs somebody like a teaching assistant that has an idea of data science. So they can reject a first class student to go and pick someone that has data science background because there's a need for that. Do you understand? So all these skills will just make you stand out, honestly. So also track the resources available to you and keep applying the tools, keep applying them. Like we said the other time, some of you said, oh, I've heard of free code camp, I've heard of this. But my question is, have you been using it? Because when you use it, you will see that it will also help you improve on your skills. But my brothers and sisters, shoot higher and you will fly. Honestly, shoot higher and you will fly. And I know you understand what I'm saying. Be disciplined. This training will be late night reviews and a little intense. You will come out transformed. I can assure you. I'm speaking as one who has also gone through it. And I will bring my plenty thoughts to a close one. Interact. I'm sure questions. You must ask questions. You must ask questions. You must, right? If you don't ask questions, then I would think, probably I'm a bad teacher because, come on, why don't you have questions, right? So I'm opening the floor. Okay. So, sorry, let me just. So I'm sure we have questions, have we? So how do we do it? All of us, we must have questions or remark or something. So I'll go one by one. So I'll start from, okay, yeah. So yes, you're raising your hand up, sister. Sorry, I don't really know how to pronounce your name. Shim Surum, right? Please teach me how to pronounce your name.
Yeah, you try Chimzerum. That's the name. At least you try to pronounce it correctly. Yeah.
I'm happy.
All right. Thank you so much. Your lecture was actually a very wonderful one. It was very encouraging too. Okay. Personally, well, like I always say, data science is something very new to me, and this is the first time I'm actually trying to do something about it, as in like do something that ends it. And I'm really very glad to be here. I mean, the push. I'm seeing people doing things. So the papers we are trying to and everything, it's been wonderful. But I still have my personal concerns. I'm doing a master's in data science, but I don't know whether to say maybe I jumped really very fast because the foundation is not there. Even though I I'm a science, I was a science, I'm still a science student anyway. So what I wanted to ask was, where can I really start from? As in, like, the whole thing that I just feel that there's a whole lot to take in. Sometimes it can be quite overwhelming. If I'm learning data science, is it like cut into two parts? Is there the industry part of it and the research part of it? So if I'm doing the research part of it, what is there any structured thing like from the scratch that we need to learn? Like you were mentioning the whole forestry, random forest, and all of those things. Those things are like they are new languages to me, but it's something I know I'll eventually learn. But is there any structure, to learn it, or do we just go ahead publishing even if you don't have the very basic knowledge of it? That's the first question I wanted to ask. Thank you.
Okay. All right. I will just answer that. Thank you for opening up and then, asking a question. I understand, even when we had ours as well, our cohort, some people also do not have the background. And, Prof will always encourage us, you will start from somewhere. And because it's a class where people are in different levels of understanding, right? So I'll just answer your question that most times to learn data science, and that is why with the training, it's data science research. Do you understand? That doesn't mean that what you will learn here is not applicable in the industry. Do you get? But it's research because the old data science. You agree with me that the old data science as a field is very vast. It's very vast. But then you are currently learning the research part of things, or the research side of things. And most of the times, I'll be honest with you, how you know how to really handle, journeying through the old data science is majorly what do you want to apply it? What are you looking at? What's the vision like? What do you want to apply this data science skill? For me, when I started, I knew I wanted to do a PhD regardless. Of course, I was in industry working and all of that. But I knew that even in the industry, there's the R&D part of the industry. So I know that for sure, this is about PhD, this is about this. So while learning data science, I'm learning it as somebody that want to understand there's something they call first principle. You want to understand from the rudiment. For example, first of all, you want to learn data science, you need to learn the language, just like where we started learning, going to school. Before you learned or you did anything engineering, you started off learning English language, then mathematics. The reason for learning those things, please, Mr. Latif, can you mute yourself? Sorry. Okay. So the reason why you learn those things is because you want to know how to communicate in whatever area you now eventually specialize in. So you learn Python, and because this program is kind of like is short, so from your own end, you can now begin to you can be intentional about learning the language, which is Python majorly. You can use R, you can use Python, but most times I'll just advise that you use Python. Do you understand? And so those two things, learn the language, number one. Then number two, be clear about what you want to apply to eventually. If you want to go into you want to do your postgraduate, somehow it will help you navigate the area you pick. For example, now, it's hard for me, now, I think I just started picking up computer vision. So I spent so much time learning, machine learning models, the traditional supervised, unsupervised, but I didn't really spend much time on computer vision because you agree with that. Most times when you want to apply it directly in the industry or people that do freelance and all of that, they do more with computer vision, all of those gigantic, models that you spend months. But this one is research. You want to know if this particular type of data will respond to this kind of particular type of model. So you publish about it. Oh, I noticed this one is performing well with this one. Oh. Because eventually the people working in the industry, they will need these papers. They don't have time to conduct this research again. So when they are doing those big projects that are multi-billion dollars projects, they will pick up these papers that we are publishing and put them together and turn them to the GPT you're seeing today, the language models you're seeing today. They are product of the research. So people know that this model will perform this way, this kind of data will perform this way, or if you do this, this will be, that's all we're doing. Do you understand? But what we're using to do it is the language, Python, R, whatever it is. So the first thing is learn the model, then find out what you want to do with it. I hope that answers your question.
Yes, thank you very much. I think you're actually just reinforcing what Prof also said to first of all learn Python. Then again, I have a science background, chemistry precisely, and most times when we do research for us, it's either you're going to the lab to perform experiments or you're going to the field. So I wanted to know, I've observed so far that there's nothing like that for data science research. So most times the data sets are already online. or there a point you need to gather that large amount of label? And I'm just wondering, could there be a time that you run out of data to use as if what is already available?
I believe that even with this data science was the chemistry background. Say, for example, you want to do, say, catalysis, right? In catalysis, you want to do the computational side of catalysis where you use DFT, density functional theory. You know you're going to generate a lot of data from that, right? So you want to predict if you dope, say, nickel with another element, and then you want to see how it will respond. Do you get? So this is how data science interface with, say, for example, chemistry, chemical engineering. You understand what I'm saying? So I think she has network issues.
Okay, I can hear you now. I didn't hear you from
Okay.
but I can hear you now.
I'm saying that, for example, I study chemical engineering and you're also a chemistry person. You agree with me that in catalysis, there is the experimental side and there is the computational side where you predict, the energy state of this element, or say you want to, say, dope an element, say nickel, as a catalyst with another promoter. Do you get? Using DFT. Yeah. Say for that one, you're going to generate a lot of data yourself. Do you get? So data, the reason why you have a lot of data online is because people are generating it from different all kinds of research they're doing. So you can generate yourself from the lab. You can generate using like computational software. You understand? And decide to study this particular application, and then you put the data set online for people who also want to explore that data set for other applications. Do you get? So you can clean the data and put it online. Then you can also put the raw data online too. So that's how you have so many data online. So you keep generating data every day, every second. Right now, we're generating data for Zoom and whatever. Do you understand? You can imagine what they will do with what we're saying right now. So I just hope that answers your question.
Yes, thank you very much.
All right. Sister or brother Abisola, sorry if I'm not sure about the gender. You can unmute
Good
yourself.
evening. I'm not brother Abisola. I'm Abisola.
Yeah, that's why I say sister. Oh, sorry.
Okay. Yeah, no
All right.
problem. Yes. Okay. So for me, lately is even part of what stall what I'm working on the project for me, because I don't want to just jump into something I don't fully understand. So I'm taking a data science course, and for me, the pattern I've seen. Can you hear me? The pattern
Yes,
I've
I'm
seen so far. The pattern I've seen so far. I just need more clarity on it. Is that so? I've worked on like 3 sample projects, basically using linear regression, and they are all classified under supervised learning. So predicting house prices, I think it's a common project based on area, predicting house prices based on the when I said they are the square feet, the other one is based on location, based on like 3 different what's called like that. But so far, what I've seen is that usually you get a data set. The first step is usually preparing the data, and then we try to create a wrangle function that will help us data wrangling, and then cleaning the data basically. Then we get to the point where we visualize to see what the data looks like, and then we now split it into test and then train data sets. So at the point of splitting, we have to select the features I want to use. So based on, for example, if I have let's say I exported the data set as an Excel file and I have multiple columns, I will only select relevant ones to what I want to do. So we'll select the features, and then we'll call on the either linear regression model, we'll train it, and then we'll create a baseline. Then we now feed it remaining data to predict. So it's not looking like, so for me, because before now I used to see data science as one very, very tough, difficult thing to do. Because so far, that has been a pattern of what I've been learning. So I see that, for example, they already made models that all I need to do is to call it and use it to train my fit my model with my data set to learn the pattern of my data set and predict. Like, is that the whole idea of data science? That's just what I don't understand.
Okay, so to answer that question, I want to ask like a further question. Like, what's your background? Like your course, like the course you studied in school?
Yeah, computer science and engineering.
Exactly. So, okay, so to answer that question, right, I will just say that see data science as a data science researcher, right? You are more like you are trying to give a general formula. People call of a quadratic equation. They call it this formula. They call it the almighty formula, right?
Yeah.
Okay, you just plug in your numbers, plug in your variable, and then you'll be able to find A, B, and C, 2 value of X. And then we look for X, 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 X. So what these people are doing, or what they did, for example, the random forest, the naive Bayes, all of that, they are just general formulas. Do you understand? So I think, okay. So it was second year in school. We did a project on biogas. And so we took our data, took it to the lab, did FTIR, and then we came up with data set. So we now wanted to use that data set to get like a formula that we can plug in and calculate our biomethane potential. Can you hear me?
Outside.
Sorry, Sister Abigail, please can you mute yourself?
If those things are under the sun, it will be spoiled.
Okay. So we have our data set. We now want to know the content of the gas. Oh, how much methane is there from the data set? So from the FTI, if you're familiar, you see is a lot of contour lines, like a graph, just all kinds of wavelength versus whatever. But then what I took away from that project is that all we are trying to do, because we're able to just do regression and all of that, just like you have your straight line graph, and then you later come up with y equals to ms plus c. So that every time you know the intercept, you know the x value, you eventually find your y. That's what you're trying to do. So you're trying to build a kind of model, right? For example, there was a time, there's one of my friends also that worked on that prof. His name is Bola. Probably at some point also, he will also take you guys. So there was a time we worked on a project. So we wanted to build a model that will, they can deploy in the oil and gas sector. You know how big, they are big on safety, in the oil and gas sector. So we built a model. It's like a computer vision project. So this model, they were able to screen all kinds of pictures where we trained it with a lot of images, a lot of it. So what we want to do actually is to identify any oil and gas, worker on the oil platform that is not using PPE. So it can scan you, and once you are not using PPE, it will just flag you. So we trained this over several models, and then we now saw, about maybe 2 of them were combined, like Mr. David was saying the other time, talking about sample methods. That's a combination of several traditional methods together to see if the performance will improve. And right there, we saw, improvement in this particular model work, this one works. We wrote a paper about it. In fact, we wanted to present it in a SP, Society of Petroleum Engineers, the national conference. It was accepted, but after a while, we couldn't do it due to some technical issues. So, meaning that in data science, you don't just do classify, get your test data, get your train data, and validate. No, that's not all you're doing. What you're actually doing is that the reason why it feels like that is because what you're doing is the back end. Now there is the front end. If you put in your password on a website or in a website, you put in your password from the front end, it's going to go down to the back and check through the list of data to see if there's any password assigned to that username, if it's correct. That's what it's doing. So assuming after a while, you start building the front end of this back end you are doing, and you begin to appreciate what you're doing, right? Because when you plug in from the front end, you see the beauty of what your model is doing on the back end. Do you understand what I'm saying? So it's not just...
So in other words, you're saying that those things are like abstractions, and we just call those methods.
Yes, the methods, it's just you building a general, just like the name model. Model is just to give like a summarized understanding of a particular concept, so that the next time you want to, and that's why they call it deploying the model. Is already a general formula. You just call out the formula, x equals to this and that, and then you just plug and say x equals to 2. Your ability to now interpret why the implication of y of x equals to 2 is another thing. Do you understand what I'm saying? For example, if you're using accuracy, or you're using, say, what's the name of this thing? Borrow me some of these validation metrics that we use. What's the name? It just skipped my mind now. Accuracy, precision, recall, and all of that. Log loss, there's a log loss, right? So if you deploy those things, now your ability to interpret an accuracy that is more than 80% and a recall that is like, say, 0.5, 0.5, these are just numbers to every other, person like seeing your work. But to you, you're able to say, this one performed very well. This means that this model is real. This means that this is this. So the interplay of these metrics is what will help you know if your model is performing well. In the true sense of it, that's all these mathematicians do. They have metrics, they have things, and that's why the most popular one in statistics is this R-square. They'll tell you, even people that do statistical learning, they do any project, they'll tell you that my R-square is more than 0.9. Do you understand? for them, they're not just numbers. Do you get? Is interpreting the accuracy of their work. I hope that answers your question.
Yes, but then I wanted it to more like I needed a validation on that's more like the pattern or the flow, the end-to-end process of what data science is really about. But I think you already said that.
That's not all it's all about, but it's mostly what
Okay,
it's all
but
about.
at least yeah. Okay, thank you so much. Thank you.
You're welcome. Any other question? Any other question? Okay. Okay, so excluding those that have asked question, I will just call every other person to give a remark. If not, question. I want you to say something. I want to hear from you. Mr. Latif, I'll start from you. Just a short remark, just something. Just say something. I just want to hear your voice. That's it.
Okay, good evening, everyone.
Good evening.
I actually joined late, but I got something. So I think, thank you for that question, Pusa. You're like me to have like, is data science all about, it's all about, I used to feel like data science, like I'm doing data analysis. Using my Excel, Power BI to do data analysis. I'll do my, what is it called? Do my pandas. I look for I used to feel like it's not a lot, honestly. I used to feel like it's not a lot. But with your explanation tonight, I now understand that data science is very deep. Very deep. Like you have to create your models and then like you explain the interface, like the front end and the back end. I understand better now. I understand what it is. And I think I need to learn more.
Yeah, that's great. So I'll go to Star Abigail. I don't know, maybe you've asked a question, but yes, please, you can unmute yourself. Just a little remark.
Okay, good evening, sir. I want to say thank you for the class. Although I don't have much to say, but it was really a nice one. And then I hope to learn better subsequent days. So I don't really have any question. Just observing from the back. Thank you, sir.
That's great. Thank you for your remark. I think, okay, I'll go to Sister Iberi. Yes, I think, yes. Please, you have the floor.
Thank you, sir. Good evening once again. I don't have a direct question at the moment, but in the course of your teaching, you answered a number of questions on my mind. Thank you for the presentation. It was well clear, and I have learned some number of new things which I'm going to apply. So your starting point was also like very catchy for me, talking about how you were like in a point of transition. I came across this program and you were wondering, should I continue in the industry or should I go into the academia? I think it also like applies to me. Certain times I wonder, does it worth it going further for a PhD or I already have 2 MSc, should I just continue and run with it that way? But looking at it at the long run, I feel like if I want to solidify my stay in countries outside my country, I need that PhD. So I can relate to that. It's really that's your insight was really helpful to me. Then secondly, the question of mastering nitty-gritties of some basic tools. Okay, recently I was asking myself, I know Python to some extent. I was like, do I need to go further to solidify the nitty-gritties? Not just going on GitHub or any other place to import all of this code, but being able to understand the nitty-gritty, why this is this and why that is that. I think you did explain and highlighted that in your teaching where you talk about we can use free code CAM to know why this is this and that is that, understand nitty-gritty. So you have answered the questions on my mind, and I really have a lot of take home from tonight's teaching. Thank you very much.
No, you're welcome. That's great to know. So I'm not sure Mr. or Mrs. Sorry, Abiodun, right? Or his brother or sister?
Good evening, sir.
Okay, his sister. Sorry. So you have the floor. Yeah.
Okay, thank you very much for tonight's session. Actually, most of the questions on my mind have been answered, but I don't know. I would love to add this. I don't know I don't know how to put the question, but I just pray you are able to understand. It's not really related to this class, to tonight's session. So my question is, I still get confused about this difference between data science, ML, and AI. So now, late last year, stroke this year, I was trying to apply for PhD too, like fully funded. although I've prepared most of my letters, but then I don't know if I should say I want to do my PhD in computer science, like PhD in computer science, then how do I put it now? In computer science, but my area of specification of this specialization is data science in healthcare. So I don't know if I should say data science in healthcare, I be ML in healthcare, I like the whole thing is just, I just look for a way to put something in my letter. So I don't know if there's a way you can just help me state the differences and how best to like put the whole thing together. I did statistics, but I want to do computer science, but then in data science, healthcare. I don't know if that question makes sense. So I don't know if there's a way you can just help me structure the whole position, if that's correct. So that's
Okay.
yes, that's it, sir. Thank you.
Okay, so I understand very, very well. So for AI, actually, it's like a broad concept. Do you get? Machine learning itself is under AI. It's a subset of AI. You get? So machine learning is a subset of AI. You understand? So AI is more of like you're trying to create a system, a broader system. But machine learning is like you are trying to train a machine with data sets. Do you understand? For AI, for example, you know there is data engineering, there is data science, there is data analytics, right? Now, for data engineering guys, they build pipelines. Pipelines is like how to harvest data. You want to get data from different sources and all of that. They are the guys, they are the ones building the pipelines from the back end. Do you understand? So to build a whole AI system, you need more than just a data scientist.
Okay.
Do you get? You're going to need other expertise too on how you continue, you keep getting data into your system, keep training your system. It's a whole project. And so maybe a month or two back, like they released this Chinese AI tool. And there was a whole long fuss about it that they were able to build it with a cheaper amount than ChatGPT was so million. Why this one is just like 1/10 of ChatGPT? It's a whole project on its own. It's a system that goes beyond data scientists or machine learning experts. Even in data science, because data science is a field on its own. Machine learning, you have machine learning experts. They are machine learning engineers. They are also data engineers, but their expertise is on, more of machine learning. So it's a bit kind of confusing. And that is why the other time I was talking about knowing your niche, knowing where you apply this thing. There are people that okay, go ahead. Please, can you mute yourself? I think. Okay. So, like, data science is a field on its own. AI is a broader system. Like, it's like you're trying to build a whole system. Machine learning is you trying to train a machine on several data sets. You understand what I'm saying? So in your own case now, if you want to apply for postgrad and all of that, all you just need to tell them is that you've learned how to. Most times you pitch. Most times it's machine learning you will pitch, or you've learned several machine learning methods and you've used it to work on several. So you know how to deploy machine learning models to apply it in so and all of that. The most important thing is that your problem solving skills. You know how to define a problem, then you know what tool to deploy. You know what model. For example, I was talking the other time about if you have a continuous data, for example, that you're not going to go to your traditional methods. They will not work. You go to like specific models like LSTM, CNN. You already know because it's a continuous data. Do you understand? So those skills, that's just all you're picking up from your data science research, most times for the PhD and your postgraduate. So all you just need to tell them is that your skills, you have skills in machine learning methods, and then you use it to work on so and so. Right. So you can't really say you're an AI person, expert, because you will need more than just data science to do AI.
Okay.
Machine learning rather. You need more than just machine learning, or there are other tools that data engineers use that we don't use. You get?
Yes, sir. Okay, thank you so much, sir. Thank you.
You're welcome. So I don't know, somebody, Mr. Olawale, I don't know. You can, okay.
Yeah, can you hear me, sir?
Yes, I can hear you.
Okay. Oh, thank you so much for this session, sir. First, I want to commend you for the teaching skills. I actually recognize that you're actually a good teacher. Thank you so much for that, sir.
I'll take that. Thank you. Thank you.
Yeah, I just wanted to chime in on the last person's, just to add my comment to the last person's question, because we happen to have some similarity in background, although because my background is also in statistics, and I have some, or let me say, graduate certificate program in biostatistics. So I just wanted to add, just comment on that. So I could just recommend that the person who has a background in statistics can look at public health programs, for instance, when it comes to biostatistics for a PhD program. Biostatistics is not called data science, but then most likely you will need to have some programming skills to support you. And the person can also explore bioinformatics or computational biology. The good thing for some people is that their background is different from statistics. Maybe they are medical doctors and the likes, and that could be very helpful because when you have a domain expertise, when it comes to medical research, when you start making presentations, you are able to make something sensible to the people you are speaking with. But for somebody who is not a doctor, who does not have a medical, he is used to writing the code, writing program. And another thing I want to add to it is that this thing is not just knowing just having the hands-on skills. You should also have the soft skills too, because after you've done all the coding and the likes, the people you are presenting to, they may not be interested in all the codes you have. What they are interested in is the result. Like, are you able to tell them something that makes sense to them? Are you able to solve their problem? That is, so ability to code is good, but alongside, one should be building up your ability to be able to connect with people, have the domain knowledge, even if your background is not in medicine, maybe it's in chemistry or other science. I just want to mention that you should know that if your background is not programming, you have other background like chemistry, like finance, is also good, because if your research is in that area, you'll be able to communicate better than somebody who does not even have that background. So you should rather leverage your background instead of thinking, well, my background is not data science, it's not this. You can incorporate data science into your field to make you even an outkick. So I just wanted to add that to it. And if the last person who asked question also wants to pursue PhD in data science, you can as well do that. You can pursue PhD in data science and see the curriculum if there's a possibility of you finding a way of carving out a niche, or let's say the professor you are working with. If you choose a professor that the area the professor works on is more inclined to medicine, then you could select that professor and work with him. And in that case, you'll be working in the area of your interest. Thank you, sir.
Thank you so much. I think you even answered that a lot better than I did, but that's wonderful. Thank you so much.
Thank you so much, Mr. Olawale. Thank you.
So I'll go to Mr. David, a short remark. Mr. David, I think you even opened the meeting, with your slide. Yeah, but that's beautiful. Thank you. So go ahead.
Thank you, sir, for the lecture tonight. It was really impactful. I would say, for me, one thing that stood out to me from what you said is the fact that in data science we learn on the job, and that just reminds me of my own personal experience on this journey. I've been in this space for almost 2 years now, and I can relate with what the question someone asked about trying to find a path to understanding the nitty-gritty of data science and machine learning. And what you said just reminded me of the fact that it's easier to learn when you are working on projects. There's what they call project-based learning now, which is even if you're not really familiar with a concept, working on projects, even something as basic as Python, there's a way you can learn Python by working on projects. And that's why this research training has really been impactful for me. Learning new concepts while also doing and applying those concepts at the same time. So thank you again, sir, for the lecture.
You're welcome. Thank you so much for that remark. I think that just further explained Sister Shimsorum's question. Really nice. Thank you. So I'll go to Brother Mr. Nwachuku Samuel. A short remark from you.
Good evening, everyone. Good evening, sir.
Good evening.
Thank you so much for today's lecture. Actually, this is my first time of hearing about
So please, if you can add a little volume, I think we can hear you. So
okay. Can you hear me?
Okay, I think it's better.
Yes, the whole thing is a bit not really cloudy, because at least understand the language, but there's so much to learn to catch up. But thank you for the high opinion of the things. I think I can start building something. But my question is this. Having gotten a data set, now, how do we determine okay, let me ask, what's the next thing to having a data set in particular research, talking about treating, training, all those language, yet to understand many of them. So just explain briefly what's next to do having gotten a data set in particular research.
Okay, so briefly, I'll just say that once you have your data set, which is like the raw thing that you just get from the feed, say you are doing like a social experiment, and then you take people's age, you take when they take dinner, you take their height, you take their all kinds of information, right? Not all those information, you will not have all those. Maybe you will just what you want to determine if if there's any likelihood that they will develop a certain disease. Do you get? Not all the data or all the features or the parameters that you've taken from the feed will actually contribute to your research. So first thing is you clean your data, because even if people taking the data, sometimes they write 23 full stop or all kinds of different minor errors that you cannot process into your own Jupyter file. It will be giving you error. So you need to clean it. There are some empty, say you have like an Excel file, there are some columns that will be empty. There are some that if you're taking for 100, they call it respondents. If you have 100 respondents, yes, maybe there's a particular missing. You have like for the age, you have 98 people, and then for this one, you have 64. You can't train that kind of data set cells. You can't train your model with that kind of data set because it's not it's not what's it called? It's not equal. If you do matrix in mathematics, there's called something 3x3 matrix. At that point, it's not 3x3 anymore until you fill the empty cells. Do you understand? So that's what you clean. They call cleaning. You clean your data set and ensure that it fits for what you want to apply it to. So training data set, actually, the word training is that you have a machine. Do you understand? Okay, for example, a typical example is you have a dog. You just purchase the dog and then it's just not familiar with living in your house. And then you now want to train the dog on when you're going to be feeding the dog. So, in fact, it's even, I think they call it Pavlov theory in biology, secondary school biology. And they say, oh, you keep training this dog, you give the dog food every 2 a.m., say 2 a.m. or 2 p.m. every day. By the time it's 1:59 p.m., the dog will start salivating, waiting to get the food from you. What you've just done is you've trained the dog through several data sets. That means every day you're coming with food. After a while, the dog, the moment you're coming 2 p.m., is already salivating and jiggling the tail so that it's expecting the food. So just like that, your machine also is learning data. So whenever it has so much recognized this data that anytime you bring a data that is not and that's what you call your what's it called? Your test, your test data. You've trained the data with a particular different data, but there's a new set of data you are putting or you're running through the machine. He has never seen that data. So what you want to do is that you want to see if the machine will be able to pick out the erroneous ones. Do you understand what I'm saying? So if you're running your test data through the machine says, no, this one is 0, this one is 0. He has not seen the data before, but he's able to identify that, no, this one is not correct, this one is wrong. Usually that is common with classification problems. You take an experiment and then you run it through your machine. You have a model that can predict if somebody is going to have cancer or not. So after a while, you train it to like maybe 40% of your data sets or say 60%. Then the remaining 40% that has never been exposed, the machine has never been exposed to that data set, you now run it through to test if your machine will be able to predict correctly from that data set with no prior understanding. You'll be able to predict if this patient D, will have cancer or not based on this information. So if your machine can correctly predict, say 80% of your test data set, that's what you call your accuracy. That's a metrics. So once your accuracy is over like 70 something percent, 80%, you now plot your what's this quadrant? What's the name now? And you find the exact data that are correctly predicted, the true the ones that are false, and then all of that, it means that your model has tested correctly. I've never seen this data yet. I've been able to prove to you that I can identify patients that will have cancer based on these factors. Do you understand? Then sometimes there's also the validation data set. You get those ones are just to do the final. Okay, let's check. It's going well. That's great. I think that explains your question, right?
Yes, thank you very much. Patience.
So, Mr. Joel, we're almost done. Sorry, apologies for the extension. Mr. Joel, please, a short remark from you. Hello, Mr. Joel Ademola. Okay, I'm not sure. Maybe it's not. Okay, so Mr. Olamide. Okay, Mr. Okay, you have the floor. Okay, all right, thank you.
Yeah, thanks for the lecture, sir.
You're welcome.
Yeah, thank you very much, sir.
You're welcome.
Yeah, well, most of the questions that I have, I even asked someone that is into machine learning and data science this morning. The answer you gave is very similar to what he even gave me. So I'm happy to hear the same answer this night also to give me confirmation of what the person said. Nonetheless, okay, I just want to this simple question. Okay, how do you know the right model or the right solution for a specific data science problem? For example, if I want to do something on I want to analyze something. How do you know that I'm supposed to use linear regression for this one? How do you know I'm supposed to use sentiment analysis for this? How do I know I'm supposed to use predicting all those things for this specific problem?
I understand. First thing, of course, in data science is that you know your data sets. Once you know your data sets, you can explore. You can check papers, but most of the time, don't waste your time. Just go to ChatGPT. Tell ChatGPT, this is the kind of data set I have. I'm not sure which model to use. Can you suggest? So it helps you to just streamline your options. So from there, you can now maybe do some other literature review, check papers, and see the methods. Several authors have been using. So it helps you streamline, and then you use it. If it gives a very great result, if not, you recycle again. Oh, ChatGPT guy, it did not work. Oh, what do you think? Do you suggest other methods? So these tools have come to make our life better. Do you understand? So I hope that answers your question.
Very well, sir. Thank you very much.
Once you understand the data set, that's just the most important thing.
Yeah, thank you very much, sir.
Yeah, you're welcome. So, okay, yes, you have the floor, Mr. Olamide.
Good evening, sir. Thank you very much for the class, and it has been an insightful one. Actually, most of my questions have been answered, such as especially I've been having a challenge of figuring out how to go about learning. Should I say everything? Let me say everything that it requires to carry out a data science research, like getting data, analyzing data, and all those stuff. But I needed the background of data science, of course, and it has been a challenge to even find good resources that actually addresses the background and all. But with the roadmap that you have given, I have a structured way to go about it now, and thank you for that, sir.
Yeah, that's great to hear. I'm happy that helps. So I'll go to Miss Oluwasegun Osede. Okay, Mr. Yeah, I think you asked a question earlier. Okay, no problem. So I'll go to Mr. the last person, but of course not the last. Mr. Emmanuel. I'm not sure. I think maybe you had network issues the other time. Mr. Oyedele. Yes.
Okay, sir. Good evening, sir. Good evening, everyone. I don't really have a question, but I would just like to thank you very much, sir, for the class. It's been insightful. And I think one thing I also learned is the fact that the size space you talked about. Yes, and lots of tools that are available for us to consume.
Yeah.
And this is more like opening my eyes to the world of data science. I've never been into data science before, but I do little coding. And this program has opened my eyes to see the importance, especially publishing also, and with the help of professor and mentors coming in to take us. So thank you very, very much, sir, for the class. I'm really grateful, sir.
You're welcome. So yes, I think we've heard from everyone. Just in case maybe you also have questions about application process, you want to apply for PhD, you want one question or the other, you want somebody to review your SOP and all of that. So as part of the benefit of being a part of ADA, do you understand? You can also reach out to me. And even in some cases when you are applying for PhD and then we don't have similar background, I probably have a friend or two that also have similar backgrounds that can push you through on the process. So I'll be happy to help. That's my email. That's my WhatsApp number. You can chat me up. So thank you. So I think that will be the end for. Thank you so much for having me.
Sir, let me say something before you round up. This is just like an observation, and I'm just to air it out. Thank you very much for the session. Although it's going to my colleagues, just encourage everyone to keep their profile very professional. I think it will save our tutor a lot of stress. We had a teacher tonight that wanted to engage every one of us, but I think there were some struggles along the way addressing people with the agenda. Oh, I'm not Mr. So I'll just encourage, if you can, keep your profile professional, have a picture. I know in this part of the world, okay, in this community, we don't have a problem of other kind of gender. So if we see your picture, we'll be able to know where you fall, either male or female. It's just my own observation. Thank you.
I think that observation also goes to me. I think I will upload my picture also there, because one day I will not be the tutor on a call. Do you understand? So thank you for the observation. I will also take it as an advice for myself. Thank you so much. So I think that'll be the end. It's an honor to have be with you guys. I'm sorry it took so long, but I'm sure that it's probably worth the time. Thank you so much.